Okay, the problem is maximum building height. So we want to build in new buildings in a city. The city buildings will be built in a line in a level of 1 to n. So let's say this is one line is there. 1, 2, 3, 4, 5, 6. This is how we have to build some buildings. However, there are some restrictions are there. Height of each building must be non-negative integer. Obviously, building height should not be negative. It is not underground building. So building height must be non-negative, but it could be 0. The height of the fast building must be 0. This is a condition. The fast building, whatever the building we make, fast building is height of 0, no height, 0 height. After that, it could be 1, it could be any other thing. Let's see. And a height difference between any two adjacent buildings cannot exceed 1. What is meaning by that? The building number 2. Building number 2 can only have a height of 1 because the height of 1 is 0, so that difference is 1. Another possible case is like if it is height is 0, building number 1, building 2 also can be height of 0. So because the difference between two adjacent buildings cannot exceed 1 but can be similar. Another case, let's say some building, let's say K having height of H. Okay, so this K plus 1 building, what are the possible cases? K plus 1 building is could be height of H, same height, so that at difference between two adjacent building is at most 1. It could be H. It would be H plus 1, and it could be H minus 1. So these three possibilities are there. If any building have height H, the next building could be ranges between H minus 1, H and H plus 1. These three possible cases are there. Mind it. Additionally, there are some other restrictions are there. The city restriction on maximum height on specific building. Now specific building has some restriction. Let's say I will give you an example. Specific buildings have some restriction. This restriction is given in a 2D integer array, restriction ID and maximum height. Okay, let's give you an example here. So if my height is like this, okay, let's say my height 1 is 0, no height. Height 2 could be 1 because difference could be 1. Height 3 could be difference of height 2. Height 4 could be difference of height. Let's say this is 0, this is 1, 2, 3, height 3. Height 5 could be the height of 4. Height of 4, 5. Now height 6 could be height of 5, like that. If there is no restriction, but see here some additional building is given. See there are some restriction maximum height on some specific building. So it is given as 2D integer array restriction where restriction I is containing ID and maximum height. So let's say this is my restriction array. Let's say my ID is 6 and height is 4. That means what? The sixth building have the maximum height of, let's say not 4, let's say 2. It is given. So this is the ID building ID I. Let's say here it is ID. This is ID, and this is the maximum height. It would be possible. So that means 6 building have maximum height of 2. Okay, so it is guaranteed each building will appear at most once in the restriction. So see in the restriction only 6 and 2 is there. No other buildings are there. So it is guaranteed that if one ID is present, so that is the only one record of that related to the ID. There is no other same record like 6-3. It is not possible. So it is guaranteed that ID will appear at most once. At most in the sense it may appear once, but it may not appear. This is at most once. Building 1 will not be in the restriction. So it is guaranteed building 1 is also not in the restriction because see we know like building 1 height is 0. That's why they are not adding it. So it will not. It is kind of truth for this universal truth for this problem. Now to return the maximum possible height of the tallest building. That is the time like nth value constant. N could be 10 to the power 9. restriction length could be n minus 1 or 10 to the power, whichever is the minimum, and ID I is the unique for each and every case, and these two conditions are there. These are the condition that is not mentioned in the constraint. Okay, let's see in this example what could be my answer. Restriction is given 6 and 2. So 6 could be maximum of height 2, not more than that. If C is maximum height 2, that means it is like this, right? Okay, if this is height 2, that means no other restriction are given, so I have to adjust some other building height. So this now the fifth building cannot height have 4, because see difference is here, difference is 4 and it is height is 2, difference is 2, so it is not possible. So make it maximize, I have to make this height as 3. For this thing I have to change the height of fifth building, right? This could be 3, but this 4, this could be 3. This is not a impossible case, because see here height is 3, here is height is 3, difference could be at most 1, it could be 0 as well. So maximum height I can get from this problem is 3. Simple. This is the approach actually. So some not all of the buildings height will be given, some limit will be given for some values. For here only 6 has the limit, 6 2. Mind it, like this could be the maximum height, doesn't mean like it is always be my height. So whatever height is present here, that height is the maximum limit. This height maximum limit, this could be height of 1 as well. So anything below the height, it is possible. You cannot say like 6 is 2, doesn't mean like you have to assign a building of height to the 6th position. You can assign a building less than or equals to height 2 in the 6th position. Mind it. Okay, I will give you every cases and every example. Let's start seeing the example. First, let's see what if nothing is given, no restriction is given. What if no restriction is given? So this is the case, no restrictions are given. So if that is the case, no restrictions are given, see you can see a pattern. If no restriction are given, the number of buildings equals to k. So I can, no restriction is given, so idea like fast building start with 0 height, then I can increase the height one by one. 2 could be 3 height 1, 3 could be height 2, 4 could be height this way, 9 could be height of 8, like this way. So if you notice, you can see a pattern. You can see a pattern that ith building, if no restriction is given, then ith building is a height of I minus 1. Ith building have a height of I minus 1. So that means if k n equals to k, then what is the maximum height of the last building? If it is not mentioned, if there is no restrictions, what will be the height of last building? It will be k minus 1. I am explaining this thing just because of I need this value. I'll explain why, but I need this value. If nothing is mentioned, if restriction, there is no restriction in the last building, let's say 8 here is there, so here let's say n equals to 8. What is the height of 8? 8 is nothing, height of 8th building is 7. Similarly, if restrictions are given, then that is the maximum height. If there is no restriction, then what could be the maximum height of the last building? It could be the last building, it could be n minus 1, like n minus 1. So if it is 8, it will be n minus 1. Okay, let's see some, this is one observation. Let's see other observations. Let's see this observation. My building height could differ from here to here. Okay, so this is the restrictions, this is the without restrictions. Okay, so this could be some restriction could be there. Let's say my restriction is given here. Let's say the 10th building having restrictions of 4, 4 building having restriction of sorry, 5th building having restrictions of 4, and 8 building have restriction of 3. If this is the given, this restriction given, then this is the easiest way. See, if the restriction of 5 is 4, then starting from here I can simply increase one by one. Simple, like simply in a steady manner I can increase. Now the fifth height is 4, and 8 height is 3. So here I can create one peak like this way. This could be maximum height I can make. Then again 8 height is 3, 10 height is 4. So I can again make this kind of thing, and here there is no restriction, so I can increase one by one after this point. So here you can see the 8 building and 10 building. 3 from 8 and 8 building is height 3 and 10 building is height 4. That means I can increase the height from 8 to 10. So while increasing the height, I can 3 becomes 4. But after 9 to 10, I cannot make this height as a 5. I cannot make this 5 as a 5. Why I cannot make? Because there is a restriction of height in the building 10. So I cannot increase the height. But I can make a building of height equals to that. It is possible. You can say like you can make a building of height 3 and here it is height 4. This is also a valid. But why to make a smaller amount of building? Like, my task is to find a maximum height of the building. So let's do build a building like at most height it is possible in that position. My target is that to build a building which height is at most possible, like which possible maximum possible value I can make. So that is why I am increasing. Now whenever I can't increase or my height in the next building, I will simply say saturate the case. Saturate in the sense I make the same height. Okay, so now see, this is the case. I say this is the possible building structure is this. So if you notice, there is some dependency is there. See here, if my building is 4, if my building of 4 is height 3, so what is the next building height? So what is the maximum possibility case? What is the maximum possibility case of building 5? Building 5 could be in a range, be +1 or it could be 0 or it could be -1. Okay, what is the building 6? It could be 4 height is whatever the height is there, 6 is +2 or could be -2, because -2 in the sense why I am saying -2, let's say 5 building is second height, and 6 building is this side, of this side and this side. This is also possible. If I build a building like that, this is also possible. So the thing is, so what is the case? This 4 actually kind of has a control of height of 5th building and height of 6th building. Okay, or you can say in a reverse way, 6th building is depends on the height of the previous building. This case also it depends on the next building. So each building has a dependency. This is not this is a dependency. It's a previous building. So if I say, so what could be the dependency, like, so 4 buildings. So what is the height of 4 plus kth building? Okay, the 5th building having maximum height of 4 plus 1. Second building, the difference distance between 4 and 6 is 2. The maximum height could be 4 plus 2 or 4 plus 2. What is the difference of the 7? It will be the height of 4th building plus 3 or minus 3, in the range of that. So if my building is around, I am standing at some index at this point, this here, let's say 4, I am at the port k8 index. Next, after let's say tth building, after, or let's give this example. I am currently standing at the ith index. So ith index is there. So what is the building height of the kth after kth building? Okay, so the building height of the kth building depends on I plus k, and it will start from I plus k to I minus k. In this range, my building will be in the range of these two values. In the range, it could be plus k or minus k, both are possible. See, this is a valid scenario, right? This is a valid scenario. I can give an example each and every case. What is the height of 5? 5 is difference is 1. So height is 4 plus 1, 5. What is 6 value? 6 is difference is 2. So this is 3 plus 2, height is 5. What is 7th height? 7th building height? It's 4. What is the difference between 4 and 7 is 3. So it is already in the range. You can say range is 4 plus 3, 7, or 4 minus 3, 1. So 7 to 1, it is in the correct place. It is nothing but, sorry, 3 plus 3, 6, and 3 minus 3, 0 height. So it is in the either 0 height, or it could be the height of 6. So it is in the same range. 8 is also same. 8 could be, this height is 3. 3 and difference between 4 and 8 is 5. So height could be 4 plus 5, sorry, 3 plus 5, 8, or 3 minus 5, that is negative, but in the negative we will just round it up to 0. So in this height, so every possible case you can see. So this is what we can say. So that means, like, if I present in this side, so this side it depends on the other buildings present in the left side or right side, correct? This is I want to point it out. So this is the formula. If I am is the k, so this is the next building height could be I plus k and the range of I minus k. Okay, fine. Oh, let's see some example. Um, yeah. Okay, let's see some example. Here the range is 7, 6 and 8, 4. Rest is meaning the restriction, and the shorthand I read at the rest. Okay, let's see this example. In this example, the restriction is given. Restriction is given as 7. It could be height of maximum 6 and a height 8 could be maximum of 4. This is the restriction. See, 7 actually can be the height of 6. It is possible. How? As I told you, there is no restrictions. Maximum height possible of nth building is the n minus 1, or kth building is k minus 1. The 7th is the 7th building, and what is the maximum height is 7 minus 1, is a possible case. But see here, that depends on 8 minus 4. See this 8 minus 4, that means 8 has the maximum. If there is no restriction, then what could be the maximum height of 8? It could be the 7, right? Maximum height could be 7. But as there is restriction is there, it cannot exceed the height. So 8 having the height 4. Now if I build a building of 8 with height 4, can I make a building of at a 7 building at height 6? Is it possible? Not at all. It is not at all possible, because see here height is 6, sorry, height is 4, and here height is 6. If I make height is 6 here, so it is the dependent. So at most difference could be 1, but here difference becoming 2, so it is not possible. So as I I can't increase the height of 8, so let's build a building of height 4 in the 8th position. Okay, let's copy in this block so that it looks some kind of pretty. Put it here. Okay, so my height is 4. I can make a building of height 4. See here, right now this case, now 7 have a maximum height of 6, so it is have a maximum of height of 6, but if I wish, I can make a building of below that height. So I can make a building below that height. So what could be the maximum case in this case? So it is dependent on 8. So any value is dependent on 8. Like right side, as I told you, any building is dependent on right side or the left side of the building. So dependent on 8. Okay. So if it is dependent on 8, and so then what could be the maximum value? What could be the value what the 7 can get? 7 can get one value. Let's say what is the current value of 6? The current value of 7 is 6. And what is it is dependent on right side. Right side of the value. Right side is 8. 8 value is nothing but 4, and its value, what could be the value it is possible? 4, and what is the difference with that? Difference is 1. So 4, and I am just adding 1 here. So what is the minimum of this? Minimum of this is 5. 4 plus 1 is 5. So I can make a building on 7th place with a height 6. With a height 6. That is the maximum difference I can make. Correct? So for this case, I can make a height 5. So I can make a building of height 5 in the fifth place. So I am making a building of height 5. Okay, simple. So earlier, even though maximum height could be 6, but I am making a building of height 5 for this sake, because height of 8 building is fixed 4. I cannot exceed that. So I have to adjust the height of the next building. So what is the height of the sixth building? It could be around 6, or it could be 5. So or it could be 5. So what is the maximum possible height of the index 6? It is nothing but 5, right? It is nothing but 5. So I can make a fifth building here, and same height it is. Because the 5 I can make a height of 4, in the 4 I can make height of 3, I can in 3 I can make height of 2, and it is the 2. So in this range, what is the maximum height? So assume the length is up to 8, like number of building I have to make is 8. So answer will be the 5. Here is the 5 is the answer. 5 is the answer in this case, because maximum height I can make is the fifth place. So here I can make a same height of, in the sixth place I can make height 6, in the fifth place I can make height of 4, in the fourth place I can make height of 3, third place I can make height of 2, and second place I can make height of 1. So maximum height is possible is 5. Okay, now see another example. What if only single restriction is given? Now there is a problem. If only single restriction is given, how could I compare? How could I compare? So to compare, let's say for here, this is I'm comparing with the height of 8. The height of, let's now you can argue like, then how I am comparing with height of 8. I will give you example in this example in this case. Out of house of 5, this like building 5, building 5, where could I get example? So I can, one thing you can notice, like there is one fixed rule. I can append two values. I can append two values. Two values means what? Two values means one value is first case, that is not present, 1 0. So always first building is height 0. So I can add this condition in the restrictions. So this is also a restriction, right? So first building have the height of 0. So I can add this into the restrictions. And what could be the height of, say here also n equals to 8. So what is the height of 8 here? Height of 8 is 7. Maximum height is 7. So I can make a 7 height here. Okay. So I can compare these two things. So height of this building height I can compare with the 7th height, and this I can compare the 1 0 height. So if I compare is the 1 and 0 height first, if I compare 1 and 0 height, so is it a valid position? See, height is 0. So if one having height of 0 and this is fixed, one having height of 0, this is kind of fixed kind of thing. So you cannot change that because there is a fixed value at the first place 0. So it is height is 0. Then what could be the maximum height of the fifth building? So if you notice, as I told you, if 1 is the height of k, maximum height of height k is k plus difference between 5 and 1, that is nothing but 5 minus I. So that could be the maximum value, correct? So even though your height is 6 here, so it depends on the previous value. The height is depends on the previous value. So it could be the height of case. So it is depends on the first value. So 1 is 0. 1 is 0. So what could be the maximum value of the fifth place? So maximum value of fifth place is 1 plus 4 is, sorry, 1 not 1 plus 4, 0 plus 4, because height of building 1 is 0. 0 plus 4 is 4. The maximum height could be 4. So how could I say? So current value is 6 and maximum value 1 is 0. So 0. And what is the difference between 5 and 1 is 4. So 4. So 6 and 4 is 4. So you can say the maximum height is possible here is this 4. Up to this fifth building can be 4. And you can you can know as if there is no restriction, then what is the maximum value of the 5? It's possible. N minus k minus 1, this 5 minus 1 4. That's why it is 4. So this is how we can select one condition we have to check. So if there is only single case, a building I have to start take. The building is dependent on the first building. Obviously, it's dependent on the first building. First building is 0, and the building height of this 4, it cannot be exceed more than that distance. This distance. So I have to check whether what is the given distance. Distance is given. Maximum height is given. Is that maximum height is kind of okay for that? So maximum height can see, you can see in this example it is given is 6, but I am taking which is the maximum height is possible, the 4. So you know what I am doing. I am actually here also if you notice, here maximum height is given 6, but what height I am taking? I am taking maximum height of 5. So you know what I am doing here. I am actually doing, so instead of this is the maximum height I can build a building, but I have to fix up to which height it can be possible. So I am actually uh, fixing the height of that building. So 8 I am fixing height as 4. Here 5, 7 building I am fixing the height of 5. So now it is height of 5, and now it is height of 0. 1 is height of 0. In the between of that, what is the maximum building is possible? That is a different question. I will check the question later, but I am right now fixing the height. Now you can think, how can I fix a height as 4? I am not compared anything. Okay, here also you can add two cases, like one is 0, and let's say 8 is the maximum height. Maximum height is 8, and what is the maximum? If it is not given, it is 4, but as it is given as 8 comma 4, I cannot add this height. So, and the maximum height is possible for 8 is 7. So it is kind of obviously obvious, like height of this case will be the maximum height. So you can say, like, if what if my case will be 8 comma 10 is max height of the it is in the restriction. Instead of 4 if I give it 10, then how could we cannot start with I equals to 10, so we have to do some kind of condition checks. So you will get, like, we will use one algorithm that will it will automatically adjust all the height. Okay, let's check what algorithm we could use. So see here, this is the restrictions. The restriction is given. Okay, let's jumble the restriction because it cannot be sorted. It could be any order. It could be any order. So I am making this thing. Okay, and assuming this is the order, this is given. So if any order is given, if I draw the chart, this is a I'm drawing the chart. 8 have a building of height 4. 8 have a building of height 4. Fine. 7 and 6 have a 7 building have the maximum height of 6. 10 have a building of maximum height of 8. 5 is the building of maximum height of 6. But n here given, n equals to 12 here. Okay, now see the thing. So this is a maximum possible height we can, it is given. These buildings are having this maximum possible height, but it is not said like we have to make a building of that height. What is given? We can make a building below that height. Okay, it would be equal or below to the maximum height. Cannot exceed that height. Okay, so my first target will be, let's fix the height. If these buildings I have to build in these places, I don't know what height building I have to make. So let's first fix, and I also don't know, like, what is the height it could be. So let's first fix the height. So let's first fix the height, like, so that I can know, like, this is the height of the building. Now I can make a building with that height in this place. Now how could I fix the height? I know I can start compare 5. What is the, in among all the building, among all the building, which building site is guaranteed, and I know that building height, and it is cannot, it is always the same of that building height. Obviously, that is building one. The building one's height is always constant, that is 0. That's why they have make it. Otherwise, it could be any number of answers could be possible. So we have to kind of make a constant. Like this is our kind of base value. We can say base value to compare. So instead of randomly choosing element, so 7, you can say like 8 is given. So I can compare 8 with this one. But before that, see 8 values, I know 8 values dependent, 8 values dependent on 1. This is true. This is true. But the thing is, 8 value is also dependent of height 5 as well. Similarly, the 7 is there. 7 value is dependent of 1. I know that. But 7th value is also dependent of height of uh, 5. Similarly, this 12, I don't know what is the value of 12, so I am adding two values here. So in the restriction, I will add two cases. First is 1, that is height of 0, and I always know this is fixed. This is fixed. This is the one value that is always going to be fixed. And another value that is nothing but 12, and what will be the maximum value it is possible? 11. That is not fixed. That is not fixed. It could be varies. That is not fixed. But only one value that is fixed is 1 comma 0. So let's sort the restrictions. If I sort the restriction, it becomes 1 comma 0, then 5 comma 6, then 7 comma 6, then 8 comma 4, 8 comma 4, and then 10 comma 8, and 11 comma, sorry, 12 comma 11. So this is the after sorting it. So let's make two buildings again, two buildings, because so height of 12 is 11 right now. So I have to make a bigger image. Then space, no space. That's why I'm okay. Let's make a building height 11. Copy this one. And also increase. Yeah. Okay, I guess you can see the example. Okay, fine. Okay, let's make a building here. Height of, making a very big place. So it could be 7, 8, 9, 10, 11. The height of building 12 could be 11. If it is a maximum height, it is possible if there is no restriction. Okay, so that's why. Okay, let's make it. Okay, this is the my building. Fine. Okay, so let's start comparing. So my building, so I have make two building. One is height, one is 0. This is fixed. This is 0 height, and others are in height. So how could I know like what could be the answer of my 5? So always, instead of always comparing with the one, I can, instead of, when I will take one building here, I will always compare with the left side of this building. So here, see here, I'm starting from the building 5, so I'm compare with the 1. So for the building 7, instead of compare 1, I can compare with 5. If 5 is the correct height, I can compare with the 5. Then 8, I can compare with the 7. Why I am saying? Because like, see here, this seventh building could be in the correct height in the comparison to 0th height, or first building at 0th height. But this is not only dependent on 1, it is dependent on 5 as well. Correct. Similarly, this 5 not only I have to check with 1, I have to check with the next height also. This 7 also, this 8 also, this 9 also. So first I will check with the building with the left side. Why I'm checking the left side? Because only one is present at the 0th index. This is the leftmost building. So I'm checking first with the every building which is left side building that is given. So given in the sense like 1 I have added at 0. So 5 I will compare with 1. So 5 is kind of, you know, the what the correct height of the 5. Okay, fine. So after that 7, i I can compare with the only 5. Why I am comparing with the only 5? See, if 5 is the correct height with the 1, that means 7 is also will be the correct height with the 1. If my 7 is the correct height with the 5, then it automatically takes like correct height with the 1. What I'm saying, let's say after doing the adjustment, height of 5 has changed, height of 5 has changed. So that time my seventh height needs to be adjusted regarding the 5. If it is okay with the 5, that means it is also okay with the 1. So how can I give you an example with that? Mm, how could I adjust? Okay, let's say height of the building, height of the 7, 5 is, let's say 8 here. Okay, so 7 height, what could be the height? If maximum height of building 5 is 8, what is the maximum height of building would be 6, correct? So because here difference would be 8 and 6 is 2, because that is the difference, because the difference would be the number of distance. The height, maximum difference could be the maximum distance of 5 and 7 of two buildings. So this is, if height of the 5 is 8, then height of the 7 must be 6. Okay, again, for an example, let's say some reason height of the 5 becomes, let's say 3. If height becomes 3, then what could be the height of the building of height 7? The seventh height would be obviously 3 plus 2. Maximum 2 difference is there. 3 plus, why 2 difference is say? Because this distance is 2. The same distance, same difference. So if it is 6 value, like, then if it is a 6 building, then height could be the 4. As it is a 7 building, height would be the 5. So in this case, like, 7 value is dependent on the 5 as well, and 5 is dependent on 1. So if 5 is that kind of compatible with 1, then 7 also by default compatible with 1. If it is compatible with 5, so this is transitive property is there. So if I'm checking 5, I'm checking fifth building height. I'm checking fifth building height with the 1, and I will have to check seventh building height with the 1, but I don't need to check it because fifth building height is always compatible with 1. That means by default, seventh building height is also compatible with the building 1. So that's why I don't need to check with 1. I can simply check with the leftmost building, whichever the height is given. So other buildings like 2, 3, 4, then 6, 9, 11, these building heights are not given. I have to find the height of these two buildings. I don't know what could be the height, but I know what could be the height of these buildings. Okay, these heights are given. The maximum height of these buildings are given. So I know this is the buildings. Okay, so I have to check whether this height is compatible with this is leftmost building or not. Simple that. So what I will do, I will simply start one loop from the, this is my right now restriction array. So I will simply start my loop with, let's, if I write it clearly, 12, 11, 12, 11. Okay, I'll simply start a loop from the ith index, I equals to 1 index, this index equals to 0, and simple check like whether this building is correct height with this building, whether this building is the correct height with this building or not. Check means I will adjust the height. So how could I adjust? As I told you, this is nothing but distance. What is my I? So my I is starting from, so I'm writing a loop for I starting from 1 and I less than or equals to my length. Okay, I have to find the length of the uh, length of this restrictions of restriction. Okay, so let me find the length. So length, let's say, equals to m equals to my restriction dot length, restriction dot length, And now I can write a loop for my I starting from 1 first index to I less or equals to m last index and I plus plus. Okay, I'll check this loop. So in the loop, what I will do, I will first find the distance. So first by default it is 0. So what is the index is present here? I will check with the previous index. So that's why 1 comes in the picture. That's why I added into the 1, that because so 1 it is in the question it is given 1 is not a part of of the restriction. That's why it is given. It is specifically mentioned on this rule. Like 1 is not will be the part of restriction. So that we can add it. So we can add it 1, and we can simply check whether this is the current index position is the correct height compared to the is left index height. Okay, how could I check? So let's say find a distance. What could be the maximum difference of these two buildings? So as I told you here, let's come here. As I tell you, so if I two buildings are there, what is the maximum range? So this building, this building is there. This building should be maximum of this one. This is the I plus k. This is the I plus k. This height would be the range of I plus k to I minus k. So if I stay in this building and compare this ith value and j, say let's say this is the I and this is the I, let's say. Okay, let me remove one here and say, let's say this is the ith value, and let's say I compare this jth value. So jth value will be the height of I and maximum. What is the maximum value? It could be difference between j minus I, distance between j minus I. Got it? So that's the maximum case. And what is the current j value? Current j value is something is given, some h is given. What is the minimum of that? I will take that. So why I'm taking the minimum? Let's say current j value is 4 and j index, okay, let's say the index of j is 6, and I'm comparing with the first index I equals to 0, and maximum height is, there is a, let's say there is a constant height is j, I could be 4. So what could be the maximum height of the j? Height got by j could be 4 current value, and what is the case? 0 plus 6 minus 0. 6 minus 0, why? Because I'm checking ith building is 1. So ith building is, sorry, my bad, I not 0, I equals to 1. I equals to 1 first building. So first building height is 0. What is the maximum height? 6 minus 1, it is nothing but 5. So maximum height could be 5 in the jth place. Maximum height could be the 5. Okay. So but constant it is given, let's say j is could be maximum of 4. So that's why I will take the minimum. So there's a reason. It could exceed my current height. It could exceed my current height. That's why I will take the. Okay, so I will do what? First, I need one distance. So let's say, let me calculate the distance. So distance will be my, what is the current restriction? So rest of I, current index, and current index of 0. This is the ID. Okay, minus restriction of previous index. Currently my I is this one. So I will check with this one with the zeroth index. So this is my distance. This is the distance of this two pole or this two building. This two building is the distance of that 0. 0 is nothing but ID. So this is the 0. So this is, I got the distance. Now what I need, I need to fix the height. I need to fix the height. So fix the height. How could I fix this height? So you can see 5 is height is 6. So this is not at all possible. 5 height cannot be 6. So height would be minimum of the minimum of current height that is given. Minimum of current height is given in the restriction. It is given in the restriction is I and 1. So this is the 1 and this is the index of the current height. So I11 I am writing I1, and what is the case? What could be the case? What is the height, like height of building, previous height building plus the distance. So restriction of, if I write it, so it becomes restriction of Okay, let me write in the next line. Previous column. So minimum of rest of I minus 1. What is the height of that building? That will get I from the index 1 minus, sorry, not minus, plus distance. This would be the maximum value could be possible from this distance. What is the minimum? I will assign that value into the here. So rest of I comma 0, this will be the this value. Okay, so in this case, what is the case right now? I is nothing but 5 comma 6. What is the I of 0 here? I of 0 is nothing but 5. Okay, what is I of 1? I of 1 is nothing but, here it is nothing but 1. Let's do the dry run. Let's do the dry run. Okay, so let's do the dry run. Okay, so currently my I is 1. What will be the I of 0? I of 0 is nothing but my 5. What is my I of 1? It is 6. What is my I minus 1? I minus 1 is I minus 1 comma of 0. It is nothing but my 1, and I minus 1 of 1. This is nothing but my height of that previous building. So what will be the value here? So value here will be I is 1. So distance will be previous like current distance minus the previous distance. So it will be 4. The distance becomes here. Distance becomes 4. Nice. Then what is the minimum value? Current is what? Current value is 6 here. Current value is 6 here. And current value is 6 here. Current value is 6. And what is the previous value of previous pole distance? Height is 0. 0. And what could be the maximum possible case? 0 plus 4, or like previous plus distance. 0 plus 4. So it could be actually 6 comma 4. What is the minimum will be? It will be 4. It will be 4. So minimum of these two becomes 4. So height of the fifth building would becomes 4. See, this will becomes 4. So this is reduced. So I will update this in place. So that's why this 5 is place, it will be updated as 4. Okay. Okay, fine. Okay, let me write in the below. It will be easy to understand. So it is height, earlier it was 6. This is 6. This is 4. This is 10 is 8. Now I'm writing as 11. Okay. So it is updated by 4. Okay. Now I becomes 2. When I becomes 2, I of 0 becomes 7. I minus 1 becomes 5. This becomes 6. And this becomes what? This becomes height is and becomes 4. So is it in the correct place? See here. So what is the current value? What is the current value? Distance, what is the distance? So distance becomes 2. Distance is 2. Distance is 2 because 7 minus 5 is 2. So there is 2 distances there between these here and here. 2 is the distance, right? If 2 is the distance, so what could be the height? Height is in the correct position, is it? So given value is 6. Given value is 6, and maximum value is rest is like previous value is 4 plus distance is 2. So minimum of this 2 is 6. So this is in correct place. So it will become 6. This is fine. So what is the next case? What is the next case? The next case is, let's remove this one. Next I go to the this place. Let's I becomes at 3. I becomes 3. When I becomes 3, what could be the I0? This 8. This becomes 4, this becomes 7, and this becomes 6. Distance is what? 8 minus 7, nothing but 1. Nothing but 1. Okay, so what is the minimum? Given is 4, given is 4, and what is the current height is 6. 6 plus 1, maximum height could be 6 plus 1 7. So minimum is 4, minimum is 4, so I am making this as 4. Now you can argue in the sense like you can see that 6, it is 6 and it is 4, but this cannot be 4. This, if it is 4, the height of the 8 is can be 4. If it is 4, see here I am calculating the height for the 8, so it is minimum is 4, minimum is 4, that's why I am taking as 4, because I cannot exceed the height of 4, but I can reduce the height of 6, right? So this the height of 7 I can reduce from 6 to 5 or 6 to 4, right? But see here, I am comparing right now any building which is the left side of the building. After some time I will do comparison with the right side of the building. That time I will update the value of this one. For right now the value compared to the left side value, it is fine. 4 is fine. I cannot decrease right now compared to the left side. For 8, value of 8. So see, value of 8 compared to the left side, it is fine. 8 cannot adjust because 8 has its limit. 7 can adjust. So when I have to 7 have to adjust. When 7 will compare to the right side of its building, so then only 7 can adjust. Otherwise 7 will not adjust. For now, what I am actually adjusting, whichever my index position is right pointing, that building I am adjusting. So I starting with the building 5. 5 is going to adjust. 1 is going to adjust? No. Whenever one turn will come, 1 will adjust. But right now 5 is going to adjust. 7 I am going to adjust with the building of same. So here 7 is not going to adjust. 8, currently my index is at 8. So 8 is going to adjust. And this point, whenever 8 has this limit, that is 4, that's why 8 is not going to adjust. But for this 8 becomes 4, now 7 needs to adjust. But I will, whenever 7's like it is 7's turn will come, then 7 will adjust. For now I am considering on the 8, so 8 will adjust. Now next point is I becomes 4. Then I becomes 4, this become 10, and this become what is 8 is the value, and it is becomes 8 and height becomes 4. What is the difference? 10 minus 8, 10 minus 8 is nothing but my 2, height is 2. What is the maximum height that is given here? Maximum height given of the height given to it 8. What is the value of 8? 8 value is 4. 4 plus 2, minimum is 6. See, now this is a term of 10. Now 10 is going to adjust, right? 10 is right now going to adjust. See, if 8 is the height of 4, 10 cannot be height of 8 because maximum difference is 2. So distance is 2. It could be, what is the height of 2? It could be at most, it could be height of 8 plus the distance. That it means height of 8 is 4. It could be maximum height is the 6. It cannot more than that because it is dependent on 8. Because current 10 is dependent on 8. So it cannot exceed the value. Okay. That's the reason it becomes 6. Height becomes 6. This is going to update it. This becomes 6. Okay, so this is a whatever my current pointer is pointing to, that is going to adjust based on its left side value. So there is a reason you will see like this value will be changed periodically, like eventually it will change but not right now. So this will be 6. Now next value is what? Next value is 12. If it is not given, I am adding. If it is given, I will not add. So because this needs to be changed as well, na? So first value and last value needs to be changed. So next index becomes 5. And you can say like why to add this building? Why to add this building? We can skip. We can stop iterating here, and we can see. So I will explain this later. Why to add in this building? I will explain it. Why to add this? Is eventually we have to add it. This is crucial. We have to add it. So I'll explain it in the next example. So it becomes at the fifth index. Fifth index is nothing but my, let's remove all the steps. I becomes 5. So fifth index value, let's put the values. I is 12. Right now its value maximum could be 11. Previous one is 10. and its value is updated. Its value is updated by it becomes 6. It becomes 6. So not it becomes 6. So value is 6. So what is the distance between 12 and 10 is 10. Sorry, 2. What is the current value of the maximum height could be 11. And what is the value of previous pool, uh, previous building? Previous building height is right now 6, and plus 2 it could be, so plus 2, 6 plus 2, 8. So minimum of these two would be 8. Obviously, because if the later building height is maximum of the 6, the building at the 12th position is the maximum, or the maximum would be 8. It cannot be more than that. So that because as I told you, the distance will be like distance plus sorry, this height plus the distance, that will be the maximum possible case. So in the maximum case it becomes 8. So it becomes 8. Fine. Now it is turn. Now it is the turn, like compare to the every building right now. Each and every case, every building is compared to the left. It's the left building, left side building. Now we have to compare to the right side building. See, this is the height of 12. Now this building doesn't have to compare with the right side value. Correct. This is not going to compare with the right side value. So to compare to the right side building, so I will have to start iterating from what is the restriction is there previous of that, length of previous, like last index, before the last index. Now this index should be compared with this value. See here, when I am changing, this fifth value is changed by this one. Now this value is going to be changed by fifth place. If it is changing, this place is going to be changed this one. This place is changed to be this one. This place is changed to be this one. Now the opposite needs to be checked. Now after this change, this value is correct position of now. After this value could be changed. Now this 8 value may need to be adjusted. May say like it is, let's say its value becomes this place. Now this value should be adjusted by this place, needs to be adjusted. This place also needs to be adjusted. If it is the case, let's see how we can change this. So we will use the same approach. Just delete. So same approach we are going to follow, but here we have to write for my index will be m minus 1. M is the length of this length, m minus 1. Then I greater or equals to 0, and I minus minus. Okay. So here I will calculating the distance. So distance will be my, now here I have to find the previous, like here it will be the maximum. I plus 1 distance is the maximum distance. Okay. So I am writing I plus 1 of 0 minus rest of restriction of current index of 0. Okay. Here similar way I will calculate the minimum. How to do minimum is restriction of I current index. Every time I will have to adjust the current index. So minimum of what is the current value? Restriction of I comma 1 minus, not minus, I comma 1 I1, then restriction of previous I plus 1, again plus distance. Why plus distance here? If the, let's say if the 11 building is height of let's say it is height of 4, so what could be the height of this one? Current height, that is nothing but 6, and height of 11 is 4, and what will the maximum possible case in this case? Plus 1, because distance is 1, so plus 1, so height becomes 5. So that's why, so I will obviously take the maximum distance. Now maximum, I told you I have to, my target is to build a maximum height. So that's why taking the minimum of current maximum height. And why taking minimum of current maximum height? Because my maximum height is kind of defined for these buildings. I cannot exceed that. That's why taking the minimum of the current maximum height, or the minimum of the, what is the case, like compared to the right side building. this height could be the minimum of the current, like it could be the smaller than this current height, correct? So that's the reason I am writing this condition. So let's start the algorithm again. So I will start from the fourth index. So I comma I of restriction of I0. I0 is nothing but right now 10. Restriction of I comma 1. This is nothing but 6. I plus 1. Restriction of I plus 1 comma 0. It is nothing but 12 right now. And restriction of I plus 1 of 1. That is nothing but the height of the 12 building. That is 11. What is the difference between these two is 12 minus 10. This is 2. Minimum I have to find the minimum of current height. Current height is 6. And what is the, okay, if you remember, I updated, I forgot to update in this place. This current now value will be 12 comma it becomes 8. Okay, so current value is what? Current value is 8, and maximum height could be 8 plus 2 10. So whenever the height of this building is 8, height of this building could be, it could be this height, right? It could be this height, but the problem is it has its limit. It has its limits at the height of the 6. So I have to take the minimum. That's why I'm taking minimum of these two. I'm considering like what maximum value it could be compared to the right building, but it should be the inside my minimum range. What is the maximum, like what is the maximum range of my building? It should be the below between the range. So that's why I'm taking the minimum of these two height. So that's why it becomes it was 6 earlier. So minimum will be 6, so it will not update. So 6 will be there. Okay, fine. After that I have to update. So this case, this time my index comes to at the third place. Index comes to third place. So it is third place index is 8, and height is right now 4. I plus 1 index becomes 10, and height will be 6. Okay, so what is the case will be? It will be 10 minus 2. Sorry, 10 minus 8. Distance is 2. What is the current value of 8 is right now? Current value of 8 is 4 right now. Current value is 8 is 4 right now. Sorry, 4 right now. What is the current value of this height is 6. 6 plus 2. What will be the minimum? Minimum will be the 4. So it will not change. 8 will stay at the fourth place. So this is fine. This is current value is fine. So right now it is fine. Now let's say 7th. So now index become the second index. Index become the second place. So index go to the second index. I becomes 2. If it is 2, value is 7, height is 6 right now. I plus 1 is 3, so index is building number is 8, and value is 4 right now. Now see the magic. As you notice, it should be adjusted, right? This 7 should be adjusted earlier. Now see this. Now this one is going to be, difference is 7. 8 minus 7 is 1. Current value of 7 is what? 6. Correct. And what is the current value of 4? Or like 8. Next building is 4. So it could be maximum of 4 plus 1, 5. What is the minimum is between this? 5. So that's why this building is going to be adjusted. So first we will every time I will check with the previous building. Then we will check with the, sorry, with the left side building, then we will check the right side building. So then it will be adjusted accordingly. So this is going to be 5. Fine. Okay. So next time it becomes index go to first index. Index go to first index. Index 1. Value is 5. Height is 4. Here index becomes 7. And value becomes, it will be updated by 5. Updated by 5. Okay. Okay. It becomes 5. So distance between 7 minus 5 is 2. Current height of the 5 is 4. Current value updated is 4. And minimum of height of the 7 is 5. Last 2, nothing but 7. So minimum height is possible, that is nothing but 4. So it will be not updated. It is currently it is a minimum. So 6 is going to be updated by, here I have to update as 5. Okay, so then index becomes 0, this become 5, this become 4, and this become 1 and 0. So obviously difference is 5 minus 1 is 4, but the thing is when I calculate the minimum, 0 is obviously minimum, doesn't matter. 0 comma height is height of this building is 4, 4 and plus 4 plus distance also 4, 4 4 plus 8, but minimum is 0. So first place value will be 0 always. So it doesn't matter, even the condition comes, it will be 0 because minimum is 0. You have to comparing with the minimum 0 value. So if I write now, so this is the, earlier it was given what? Earlier when it was given as maximum height possible. Okay, right, maximum height it could be in the range. This is the range of the maximum height. After these two loops, we find out the actual height of these buildings. We find the actual height of this building. So these are the fixed height of these buildings. Okay, hope you get it. This is how we can, from the range of the maximum height, we can find the range of the actual height of these buildings in the given in the restrictions. Okay, now we have to fill it up the buildings. It could be here. Okay, here it could be these. What is the maximum value? What could be the case? We can build in the place. Like we have to find out. Like now we have to find the maximum place of these buildings. Okay. So this is the case we know. Height could be, this is the height of these places, these buildings. Now we have to find what the maximum height present in these two buildings. Okay, in the vacant places, what is the maximum height of buildings could be. Okay, let's see the another example. So let's say this is the ith value, this is index of I, and this is index of j. Okay, so whenever we are trying to build any building, let's manually do it. In the, let's say there are some places are there, 1 2 3 4 5 places are there. So if the 5 places are there, I have to that means I am saying like distance between 1 and j is 5. So in this distance, how many buildings I can build? Okay, so how many buildings I can build in between that? Distance is 5, so distance is 5, that means 4 building I can make. In the here I can make 4 buildings, or distance is 6, then I can make 5 building here. So it doesn't matter. Let's see what we can do. So whenever I build making a building, so what can I make here? Copy, let's paste it here. In this place I can make this building of height 3 is there. I can make height as a building height of 4. Okay, and this is not height of 5, this is actually height of 4. This is the height of 4. So here I also make a height of 4. Now here again I can make another building here in this place. Instead of height of 4, I can make height of 5. Height of 5 I can make. Here also I can make another building of height of again 5. Now I have to make 2 more buildings. Here I can make height of 5 again. And here also I can make height of 5. Correct? So this is the maximum height. This is nothing but height of building is 5. Sorry, it is building is 6. Height of 6 and 5. So in this between, maximum I can make a building of height of 6. So how could I do? I have to do any kind of this kind of iteration 2-pointer method to like backtrack and make a building? Not needed. Not needed. What we could do, we know at the some point of distance it becomes my distance. I don't know at which point it will be. But at the after some point, this is going to my maximum height of building, right? So let's say at the after k distance, this is the height. So here also what is the distance between this and this. So if it is a distance, if I remove the number, if I make it as a distance, a generic distance, let's say d, it's a distance is d. So we can say at the k8 building, k8 after k8 place, I get the maximum height. I don't know what is the k value, but k is the maximum height. So it will be the distance between this d minus k. Okay. So what will be the height of the k8 building from the ith height? So it could be, it is, you can see it is increasing monotonically. Okay. So as I told you, if two buildings are there, if the ith buildings are there, what will be the height of the kth place? It will be I plus k, simply I plus k. So I, height of I plus k, this will be height of the next building. Okay. So what I actually mean to say, if ith building is height of I, so what is the I plus k building height of that? The height of I plus k could be height of I plus k. Similarly, if j having height of j, but in the right side is the jth height. In this case, in this place, what is the height of this d minus k building? Maximum it could be j, height of j minus k place. What could be the maximum height? I am asking about maximum, not the minimum height. Maximum height will be h of j plus d minus k. Correct? And these two height must be equal. So I can simply write a formula like height of the ith building is, from ith building I plus k is equals to height of j plus d minus k. This building height should be the same. Okay. Because I am considering both are present in the same k distance. So if it is k distance from I, so it will be d minus k distance from j. So formula will be h of I plus k equals to h of j plus d minus k. Just backtracking. So if I do it, it becomes 2k. If you just change the side, it becomes 2k h of j plus d minus h of I. So k, distance of k I got, k becomes h of j plus d minus h of I. So think this k is not the height of hk. This is the height of hk, kth building. Okay. So height, what will be the height of this building then? So k is the distance. So height of this building k is nothing but height of I plus k. This is the height of the kth building. So if I put this value, a kth value here, it will become h of I plus h of j plus d minus h of I by 2. Okay. So now if you just calculate it, you will get h of I plus h of j plus d divided by 2. This is the maximum height. Between two buildings. It's the formula of getting the maximum height between two buildings. Okay. So there's a reason. See here. Right now, we have these endpoints, right? Endpoints. So we have to calculate the maximum height between these buildings. That's the reason I added 12 at the last building. If it is not there, I am going to add. This is the reason. So if it is, say this is not given here, so I have to find the height of this 12 and so that I can calculate. If I don't add it here, then there could be at any possible combination would be possible. So I need this case as a H case, so that what are the if there are multiple blank places are there, I can simply calculate using the formula. Otherwise, I have to use some other formula. So that is the reason I have added. Okay. If you don't add, you can skip, but in that case, you can simply calculate what is the, if you don't add, even though it is correct, if you don't add, you can simply calculate what is the last value, 10 value. And then you have to calculate last place will be maximum of 10 plus let's say n item is there, so the height of that nth place will be n minus 10, and then n minus 10, and what is the 10th height of the 10th building plus n minus 10. This is the height will be the last building height. This is how we can calculate. Okay, so instead of that I am calculating by this way. Like I can find out, calculate the distance between two places. Not calculate distance, we calculate the maximum building height between two poles, and I can calculate. So if I write the total whole pseudocode here, it becomes, let's say, function maximum height, what is given, restrictions, and number of n is given, number of building is given, and restrictions of height is given. Okay, so I will simply add it first in the restriction. I'm going to add our case, that is nothing but 1, 0, first case. Then I am going to sort, but I told you to add the building, so I have to check that building is present or not. If it is present, I can't add it. So instead of checking building is present or not right now, we can do such a way: rest dot sort the building. You can use a lambda function to sort based on first index. So sort, so I write in a pseudocode, because lambda function differs for each language to each language. So use a lambda function here to sort based on 0th index. Okay, sort this. Now I'll write a condition: if I check last index, if it is my in item nth building is present in the restriction, obviously after sorting it becomes the last index of the case. That's why I'll check. It becomes, if find the length of the restriction case. So let's say n becomes, let's say n is the my case, so n equals to restriction dot length, I'll case. Now we'll check if my last case, restriction of last index value n minus 1 of 0, if is not equals to my last case, so then I will add into it. Otherwise I will not add. In that case I will add into it. So rest dot add, and I will add what, n, and this maximum value would be n minus 1. It could be the maximum value. And I also have to update the m plus equals to 1, because I have added in one case into the restriction, right? So m will be increased, value of m will be increased. Okay, after that I will simply use these functions, this formula, like these two loops, to calculate, like to fix the height of those buildings what is given in the restriction. I simply use the formula, like these two loops. After that I have to find the building between two cases. So how could I find that case? Okay, let me pause this and let me just resize this case, otherwise I cannot add into the single page. Okay, so I have just, even though I minimize it, it is not working, so I'm writing in the right side. So this is our case, when we're taking the example, this is our final example, final value we got. So between these cases we have to find the maximum building, okay, height of the maximum building. So we have to take one pair at a time, then we can calculate this way, right? So for that, like I calculate height between these two pair, then these two pair, then these two pair, then these two pair, and after these two pair. This is I can calculate the height, so that I can write another for loop. For my I am starting with the one first index, because see, to calculate this two pair, no need to check this one. I can simply calculate I minus 1 by this way. So calculate I starting from I to I less than I less or equals to m, then I plus plus. Okay, so calculate this two pair. What is the formula? For a formula, h of I plus h of j plus d divided by 2. This is a formula of these two buildings, right? So let's calculate. First calculate the distance. The distance is nothing but distance. Let's calculate it. Let's calculate distance d. D distance is nothing but my current index. The restriction of I comma 1 with the previous index, restriction of I minus 1 of distance I'm calculating, right? So not 1, it will be 0, 0, and it will be also 0. This is the distance. Now calculate the current maximum. Current maximum I can get. So let's say current maximum building in this range will be the, what will be the case? H of I means previous index height. So that is I will get from rest index of I minus 1, previous index height, that is of 1, first index today, plus current h of j. H of j is current index height, rest of I plus 1. So not I plus 1, I rest of I, and this I of what? I of 1 plus distance d, that divided by 2. Simple. And I have to, this maximum could be my maximum. So before starting the loop, I have to take one answer equals to 0, and I will make here answer will be maximum of previous answer. What is the answer of 50? And it could be answer of current max. This would be the case. So at the end, my answer will be updated, and I can simply return the answer. I can simply return the answer and the function ends here. This is how you can calculate the function. This is a hard problem, I understand. You just do some dry run each and individual edge cases, and then you will understand. It will be much more clear. Okay, fine. Then let's try the kind of, so sorting. It is takes sorting actually depends. See, sorting actually, let's say registration is k, height length of k of my this restriction array of restriction array is the k is the length of restriction array. So it will be big of k log n, k log k. This is also big of k. All depends on the restrictions, length of the restriction. Okay, this is also big of k, and this is also big of k. The time complexity is nothing but big of k log n, k log k, because this is the maximum, big of k log k, because k is here the length of the restriction. Space complexity, apart from taking the space for storing the sorting, we are not taking any extra space. We are adding 2 items into the extra k, but it will be big of k only. So it's like we are not taking any extra space. We don't consider any space for the sorting. So this is big of 1. Okay, hope you get it. It is a very long video. As always, if you find any mistake in this video, please let me know. And if you find any useful information on these topics, also please let me know so that I can learn. Thank you. Bye bye.